In this tutorial, we'll learn how to do a linear regression on a scatter plot in Minitab. So I have a data set here of total fat content in certain fast food items. Evidently this is McDonald's since Big Mac is listed, and quarter pounder with cheese, and the total calories. So we want to see if there's a connection between fat and calories. Alright, so let's take a look at how we would actually do this. So up at the top here, you would click on Graph, and then we want Scatter Plot. So we click on Scatter Plot, and I want to choose this one, the one with the regression, because that'll save me a step in terms of having to do another analysis. So once I click this, I go, OK. Now, I need to know which one's the x and the y variables. Usually, the data is listed so that this is the independent variable, and this is the response variable, or explanatory, response, independent, dependent. So usually they're in the columns correctly. So this would be your x, this would be your y. Again, the names for all of these things include things like explanatory, response, independent, dependent, input, output, things like that. So I'm going to double click for the y variable. So it's a little backwards here. They asked for the y variable first, so that's the second one, total calories. And the x variable would be total fat. So I'm trying to see if the total fat and content can predict the calories of the food. Everything else here I'm going to leave normal and just click OK. And let's see what we end up with. Okay, so here's a very good relationship between fat on the bottom with your x and your total calories on the y. Notice that I have a line here of best fit. To figure out what that equation is, if you just hover your mouse near the line, it'll display the coefficients that you need. Notice that in Minitab, they put the y-intercept first. So the 193.9 in this equation is actually where it's crossing the y-axis. And then the 11.73 is your slope. So if I interpret this, I would say that with 0 grams of fat, on average, McDonald's food has 194 calories, which could be or could not be true. Who knows if that's actually a reasonable number. And the 11.73 means that for every 1 gram of fat additional, the calories go up by 11.73. And then there's this number here, this r squared. That's called the coefficient of determination. I don't really want that for the quiz this week. I want this maybe for a different number, but 95% represents the amount of variability in the y that is described by x. So 95% of the variability in total calories is described by the fat content. Statisticians would call this an outstanding connection or correlation between the two. Again, we can't just assume cause and effect. All right, so I'm going to pause the video and do this again in Excel. Actually, I think I'm going to end the video and do it all over again in Excel. So I think, oh, I forgot there's one other thing you need. So the other thing you need for this week's quiz is the correlation coefficient. To get that, we got to go to Stat. So we're up here at the top. We need regression. Actually, let's go here. We're going to go to Basic Statistics. There's a couple ways to get to correlation, so I'll just go this way. Under Basic Statistics, there's something called correlation. So if I click correlation, I can then double click, and this time the order doesn't matter. So if I do total fat and total calories, the correlation is always the same regardless of whether it's x or y or x. It doesn't matter the order here. All right, so if I click OK, I get the correlation coefficient right here, which we can see is pretty healthy. It's 0.975. I could have gotten this number from this equation. I could have taken the 95% and took the square root of it, because that says r squared. If I take the square root of 0.095, I'll get a number close to this, but probably not exactly 0.975. All right, so I hope that helps with your Minitab exploration for this week's quiz.